Few subjects attract as much confident misinformation as the origin of human skin color. The phrase white skin evolution alone carries a set of assumptions worth examining. That light skin marks a distinct branch of humanity. That Europeans have always looked as they do now. That the trait arrived through interbreeding with Neanderthals, or that it emerged once in one place from a single gene. Claims run in the opposite direction as well. That light skin is a form of albinism, or the mark of a diseased or exiled population. Both sets of ideas circulate widely, and both can be tested against the same body of evidence: ancient DNA, population genetics, and what is now known about the genes that control pigment. This video works through that evidence. It asks when light skin actually became common, and what the newest ancient genomes say about the timing, why populations lose melanin at all, and what the vitamin D trade-off does and does not explain, whether lightening happened once or several times, and through which genes, what those genes are, and where their diversity is greatest. Why farming societies under strong sun never lightened at all, and how these variants moved between continents, including back into Africa. Where the evidence is contested or incomplete, that will be said plainly. Our earliest ape-like ancestors were probably pale-skinned under a coat of dark fur, the way a chimpanzee is light-skinned beneath its hair. Dark skin is not the primeval human condition. It is an African invention. When hominins in Africa lost most of their body hair and moved out onto the open, sun-blasted savanna, a process well underway with Homo erectus somewhere around 1.5 to 2 million years ago, bare skin was suddenly exposed to punishing ultraviolet radiation. Natural selection responded by darkening it. Melanin-rich skin became the standard human design, and it stayed the standard for well over 1 million years. By the time anatomically modern humans appear, Homo 1 from southern Ethiopia is roughly 200,000 years old. Genetic work on the Khoisan by Schlebusch and colleagues pushes our species origin back to somewhere between 260,000 and 350,000 years ago. Dark skin was simply what a human looked like. Africans then carried the species across the planet, into the Near East, across Asia to the Pacific, into Australia, and finally into Europe around 40,000 years ago. And crucially, even while dark skin dominated, the ancestral African population still carried a great deal of hidden genetic variation for lighter tones. The raw material was already there, just held at low frequency. So what is white skin evolution, really? It is depigmentation, the partial loss of melanin. And the newest ancient DNA shows it happened astonishingly late. In 2025, a team at the University of Ferrara analyzed 348 ancient genomes spanning 45,000 to 1,700 years ago. Peretti and colleagues. Their result overturned the schoolbook picture. For almost the whole of European prehistory, the people living there were dark-skinned. Nearly every individual older than about 13,000 years had dark skin, hair, and eyes. Light skin did not become the majority in Europe until roughly 3,000 years ago, well into the Iron Age, inside recorded history. As recently as 3,000 years ago, about half of Europeans still had dark or intermediate skin, and darker tones lingered in Italy, Spain, and Russia longer still. The details are almost poetic. Lighter eyes, blue and green, appeared in Europe thousands of years before light skin did. Blue eyes likely traced to a single individual and spread by chance or attraction, not survival. Britain's Cheddar Man, around 10,000 years old, had dark brown skin and blue eyes. Ötzi the Iceman, the 5,300-year-old alpine mummy, had skin darker than today's Mediterranean Europeans, even though he died in what is now Italy. Even in Ice Age Northern Europe, being dark-skinned was normal for a very long time. White skin evolution is not the deep root of Europe. It is a thin, recent layer laid over a dark-skinned past. Melanin absorbs ultraviolet radiation and does two jobs at once. It shields skin from UV damage, and it protects folate, a nutrient essential to fertility and healthy pregnancy, from being destroyed by strong sun. But sunlight is also how the body makes vitamin D, which lets you absorb calcium and build bone. Melanin is therefore a filter that works beautifully under a fierce sun and works against you under a weak one. This is the evolutionary trade-off at the center of the whole subject. Near the equator, protection from UV winds and dark skin is favored. Near the poles, the danger flips to vitamin D shortage, and lighter skin, which lets more of the scarce sun through, is favored instead. Now put a dark-skinned body into the far north during the Würm glaciation, the ice age that only ended about 10,000 years ago, where the sun sits low and weak for much of the year. The melanin that saved lives in Africa now filters out the little sunlight there is, and vitamin D production falls. In a world with no supplements and no fortified food, the consequences were severe. Vitamin D deficiency causes rickets, soft, deformed bones. And in women, it can deform the pelvis, turning childbirth into a lethal event. For the same dose of sun, lighter skin makes more vitamin D than darker skin. In a sunless place, any mutation that reduced melanin could tip a child from dying to surviving. Here, the two sources people most often skip completely change the picture, and they are worth spelling out because they replace a lazy story with a precise one. When farming spread out of Anatolia, modern Turkey, into Europe around 8,000 years ago, the farmers carried more than wheat and barley. They carried two gene variants strongly tied to lighter skin, SLC24A5 and SLC45A2, that were common in them and largely absent in Europe's earlier dark-skinned hunter-gatherers. But they did not simply replace the locals. They mixed with them. And that mixing turns out to be the engine of the whole change. Davy, Jew, Matheson, and Skoglund carried out a study in 2023. They analyzed genome-wide DNA from hundreds of Mesolithic and Neolithic Europeans to ask what natural selection did after farmers and foragers interbred. Their finding is striking. Out of the entire genome, the single region showing the greatest excess of farmer ancestry sits right on top of SLC24A5, the light-skinned gene, meaning selection actively stripped the dark-skinned hunter-gatherers' DNA out of that spot and kept the farmer's light-skinned version. At the same time, the region showing the greatest excess of hunter-gatherer ancestry was the immune system's MHC complex, the forager's local disease resistance genes, honed to European pathogens, were the version selection preserved. In other words, the mixed population became a genetic auction. From the combined gene pool, selection bought the farmer's pale skin and the forager's immunity. Their title says it cleanly: admixture facilitated selection. The mixing supplied the variation. Selection then chose from it. This matters for the argument in two ways. First, it is direct physical evidence that light skin in Europe was genuinely selected, not merely drifting around, not merely riding along on migration, because selection can be seen deleting the dark-skin ancestry precisely at the pigment gene. Second, it dismantles the crude "farmers arrived and replaced everyone" story. Europe's later populations were mosaics, assembled from dark foragers and lighter farmers, with selection sorting the pieces. A second wave, the steppe herders of the Bronze Age, later stirred in still more light-skinned variants. Modern European coloring is the sorted residue of all that mixing, recent, layered, and anything but pure. Now look at what those light-skinned genes are, because this is where the interrogation cuts deepest. SLC24. A5 is the gene behind oculocutaneous albinism type 6. SLC45A2 is the gene behind albinism type 4. OCA2 is the gene behind albinism type 2. And OCA2 causes roughly half of all albinism in the world, occurring predominantly in African populations. TYR, another core pigment gene, causes albinism type 1. The genes that make Europeans and East Asians light-skinned are the same genes whose more severe mutations produce albinism, and the most common form of that albinism is African. Plainly, light skin is built from the same pigment reduction machinery that, in Africa, expresses as albinism. That machinery, and by far the widest diversity of its variants anywhere on Earth, is African. The genetic toolkit for turning melanin down was not manufactured in Europe. It was carried out of Africa, where it already existed. In that concrete, testable sense, white skin is of African origin. This is the reorientation Cheikh Anta Diop spent his life arguing for. That pigmentation and the human story itself must be read outward from Africa, not inward toward Europe. Now precisely, so the claim is armored rather than loose, the common light skin variants, the everyday versions of SLC24A5 and SLC45A2, carried by billions of people, are not the same alleles as the rare, severe, disease-causing mutations that produce clinical albinism. Light skin is a partial, quantitative dialing down of melanin. Albinism is a near-total, pathological loss. So the blunt slogan, "White people are just albinos," overshoots the biology. But white skin and African albinism are two settings on the same African-rooted pigment machinery, is exactly right, and far more powerful because it dissolves the idea that whiteness is foreign, novel, or separate. It is a variation on an African theme, not a departure from it. If light skin were the badge of a distinct European branch of humanity, it should have one origin and one genetic basis. It has neither. The SLC24A5 light skin allele isn't European property. The identical stretch of DNA lightens Europeans, Khoisan, and South Asians alike. And the near-identical flanking sequence proves its spread by recent migration, rather than deep shared ancestry. East Asians lightened independently through entirely different genes, OCA2, traced to an approximately 7,500-year-old individual at Liangdao, plus MFSD, 12 shared with Native Americans, making depigmentation a case of convergent evolution, not a single racial origin. Every trait coded as European, blonde hair, red hair, freckles, blue and green eyes, straight hair, narrow noses, already occurs in unadmixed African populations. Because Africa holds the greatest genetic diversity on Earth, and every non-African population is a subset of it. Farming alone never lightened anyone. Sahelian, South Indian, Southeast Asian, Maya, Aztec, and Inuit populations all farmed or urbanized without depigmenting, because lightening requires low sunlight and a vitamin D-poor diet together. The trait migrated home. The Eurasian SLC24A5 variant was carried back into southern Africa roughly 2,000 years ago and swept through the Khoisan as they shifted from fish to herding, now explaining some 8 to 15% of their skin tone variation.